We just looked at how we can make fractions more complicated by finding equivalent fractions that have that are equivalent, that are essentially the same number, just using a different numerator and denominator. Let's see how we can simplify or reduce fractions. These are 4 special cases here. So in our first case, we have 7 over 1. So we can reduce that down. Anytime you see 1 in the denominator, you can simply eliminate it and it will just come out 7 or whatever is in the numerator. Sometimes we have the same number in the numerator and the denominator. When we see that, we can reduce that down. We can divide the top by 7, divide the bottom by 7, and we get 1 over 1. And we just talked about if we have anything over 1, we can just take the number on top and call it a day. So that leaves us with simply 1. It is possible to have 0 in the numerator. When we see that, it's essentially the same thing as saying 0 times 1 over 7. Anything times 0 is 0, so it's simply going to be 0. So whenever you see 0 in the numerator, your answer is just going to be 0. Now, we run into problems if we see 0 in the denominator. It will cause a rip in the entire universe and black holes will be created, destruction of all things. You do not want to see 0 in the denominator. If you see 0 in the denominator, it becomes undefined. There are times where you're going to have to check and make sure there can't be a 0 in the denominator, but that's going to be in future units. For now, just know if 0 is in the denominator, the number is undefined. So let's look at reducing fractions into its lowest terms. When we do that, it simply means that they have no common factors in the numerator and denominator other than the number 1. So when we reduce a fraction, we're going to divide the numerator and denominator by the same number. A lot of times it can help to factor. So let's look at this first example. We have 9 over 12. So 9 factored out is 3 times 3. 12 factored out is 4 times 3, which factored further is 2 times 2 times 3. But we can see the only common factor they have is 3, so we don't even need that guy. So we can divide the top number by 3, divide the bottom number by 3. Or if you like factoring like this, you can simply cancel them out. And you will get 3 over 4. So how could we cancel these out? Well, looking at the rule that we had above, we have a number over the same number. It reduces to 1 over 1, which is 1. 1 times any number is just going to be that number. So that's how it reduces down to 3/4. Let's look at 6/10. Let's maybe try to be a bit speedier with this one. Let's talk it out. The top is 5 times 2, 10. Bottom is 3 times 2, or 6. So if we divide the top number by 2 and the bottom number by 2, we're going to get 5/3. And that is as reduced as it's going to get. Now let's look at multiplying fractions. So we're going to multiply the pair of numbers. When we multiply fractions, we multiply the top, we multiply the bottom, and then we put the numerator in the numerator, the denominator in the denominator. I'm actually going to start with your first student-led example, so this one's a freebie for you guys. So in the numerator, we have 6 times 7, and 6 times 7 is 42. In the denominator, we have 7 times 12, perfectly okay if you want to use your calculator. That's going to give us 84. So I am seeing we have 42 and 84. 84 is 42 times 2. So the top number is divisible by 42. The bottom number is divisible by 42. So I'm going to reduce that down. And your final answer is going to be 1/2. Another way you could tackle this problem if you don't like dealing with larger numbers, you can factor before multiplying if you want to. So on the top, we have 2 times 3 times 7. On the bottom, we have 7 times 3 times 2 times 2. We factored 12 out before. 3 times 4 is the same as 3 times 2 times 2. And we can take out a 2. We can take out a 3. We can take out a 7. And that leaves us, there's nothing left on top. We do not put a 0 on top when there's nothing left on top. You have to make sure you put a 1 up there. If something reduces down, remember, it becomes 1, not 0. And on the bottom, the only thing left is 2. So we get the same number in 2 different ways. So you can choose which way works best for you. Now let's look at this teacher-led example up here. It's a little bit different. So one of the rules you'll have to remember when you see a whole number is it's exactly the same thing as multiplying by that number over 1. So it's the same thing as 8 times 1 over 1 times 4, which is 8/4, which reduces down to 2 over 1, which, as we saw above, is the same thing as simply saying 2. So I'm going to have you guys work through the rest of the student-led examples and see how you do.